In this video, we're going to be discussing increasing and decreasing functions. What I mean by that is if we take this function, if we move along the function from left to right, the function is constantly changing. What I mean by that is the gradient of the function is constantly changing. In other words, the rate of change of the function is constantly changing. We can split this function up into distinct parts, which I'm going to do now. I've split the function up into 5 distinct parts. The part from A to B, as you can see, is an increasing function. The value of the function is getting larger and larger. This means that between A and B, the gradient is always positive. So there we go, positive, 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 until it gets to part B. At B, the function has no slope. There is no rate of change. So that is a stationary point. After part B, we can see that the gradient is always negative until we get to part C. Negative, 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 negative. Then again, at C, we have no rate of change. The gradient is 0. Then between C and D, we have an increasing function where the gradient is always positive until we get up to part or section D, where again there is no rate of change. The gradient is 0. Then between D and E, we have a decreasing function until we get to E, where again we have no rate of change, a gradient of 0, and then between E and F we have an increasing function with a positive gradient. We can say we have an increasing function when f dash of x is greater than 0. We have a decreasing function when f dash of x is less than 0, and we have a stationary point when f dash of x equals 0. A typical IB question is as follows. Consider the function f of x equals 2x cubed minus 3x squared minus 3x plus 2 between the domain minus 1 and 2. A. Find the x coordinates of any stationary points. B. Find the range of values of x for which f of x is an increasing function. C. Find the interval in which f dash of x is less than 0. The first thing we need to do is draw this function on our TI Nspire. If I open the TI Nspire to a graph page, I can now type in the function 2x to the power of 3 minus 3x squared minus 3x plus 2 but I want a restricted domain, so I can go to Control equals vertical line. My restriction is from -1 less than or equal to x less than or equal to 2. If now I press enter, it will only draw that part of the graph. So there is my graph going from x is -1 to x is 2. First thing I need to do is find any stationary points. I can clearly see that there is a maximum there and a minimum there. So if I go to Menu, Analyze Graph, I'll find the maximum first. So my maximum is when x is 0.366. Now I'll go to Menu, Analyze Graph, find the minimum. And my minimum is when x is equal to 1.37. I now have all the information I need to answer all three parts of this question. Part A, the stationary points. Well, the stationary points are when x is equal to -0.366 and when x is equal to 1.37. The function is increasing in two parts. It's increasing when x is between -1 and -0.366, and when x is between 1.37 and x is 2. The final part of the question is to find the interval in which f' of x, or the derivative, is less than 0. In other words, it is a decreasing function, and that occurs when x is between -0.366 and x is 1.37. Notice that for part B and C, I put less than and not less than or equal to, because at the stationary points, the function is neither increasing nor decreasing, it is stationary.